Welcome to Unit 3, Day 3. Now we're going to get into solving compound inequalities and then graphing those as well. So first, what is a compound inequality? It just means we have two or more, only really do two in this class, inequalities at the same time. Meaning we're going to have one variable, but it's going to have to satisfy two different inequalities. So there are two types. There are ands and there are ors. The ands are going to look something like 2 is less than x is less than 10, or the ors are going to look something like 2 is less than x or 3 is greater than x, or something like that. All right, so this looks a little bit different. We can write the ands as 2 less than x and x less than 10. Notice that the symbols are facing the same direction. If I try to get x on the left-hand side for this other one, it'll be a little bit easier to see. Oops. That'd be x is greater than 2 or x is less than 3. I need x values that solve both of these. So in the and version, numbers like 3, 4, 5, 6, 7, 8, 9, and 10 all fit between 2 and 10. But for this one, I need explicitly numbers that are bigger than 2 but also smaller than 3. So it'd be like 2.3, 2.4, 2.7, things like that. Okay, so we're going to start with solving and graphing these compound and inequalities that are also called conjunctions. That's a fancy word. There are two ways to do them. We're going to do one for each way. So the way that I use, that to me is the easiest, it's the fastest, it's the laziest, is when we added and subtracted on both sides of an equal sign, it's the same thing, but now there are 3 sides. So I'm going to add 8 because I want to get x by itself in the middle. My goal is to get x in the middle by itself. So negative 2 plus 8 is 6, less than or equal to 3x, less than or equal to 18. Now I divide by 3, but I divide by 3 on all 3 sides. 6 divided by 3 is 2, less than or equal to x in the middle by itself, which was my goal. 18 divided by 3 is 6, so my conjunction, my and, is 2 is less than or equal to x is less than or equal to 6. So I need 3 numbers on the number line. 2 and 6 are perfect candidates, and I'll put something between them. So I'll go with a 5. I'm going to first look at this piece. Between the 2 and the x, there is an or equal to, so I get a closed circle. Then I'm going to look at that piece. Between the x and the 6, there's an or equal to, so there's a closed circle. Now we can do this a few different ways, but with conjunctions, we just connect the dots. That's the fastest way of explaining it. All right. Now for the other way, I'm going to show you kind of the other way of doing it and the other way of graphing it, which will give us the same results. So I would split this into 2 separate pieces. When I'm splitting it into 2 separate pieces, the thing in the middle is in both inequalities, and then I just split it exactly how it was. And now I solve each inequality individually. So negative 8 is less than 2x, which means negative 4 is less than x. And over here, I would subtract 3 from both sides to get 2x is less than 4. Divide by 2 to get x is less than 2. So I have a negative 4, and I have a positive 2. I'll throw a 0 roughly in the middle. All right, should be a little bit closer to the 2 end of things, I suppose, so I'll move it that way just a little bit. And now I'm going to graph this blue piece as if it was its only thing. Open circle there. X is bigger, so it's going this direction. With x less than 2, I have an open circle there, and it's going this direction. These 2 lines run into each other, so instead of having them both written, I connect those 2 because that x is greater than negative 4 or negative 4 is less than x would keep going to the right forever, but once you get over here, it does not also satisfy this x is less than 2. That's why it has to stop. So, pros and cons for each of these. main pro, there is less writing involved here. The con is every year students forget that they're supposed to do it to all 3 parts. If you only do it to 2 parts, it's going to give you at least 1 wrong answer, so you've got to be careful. Pro with just, and thing in the middle, you connect the dots. When you connect the dots, you're good to go. Downside is, well, what if you don't remember if that's an and or an or thing? You put the wrong thing and you're not actually thinking about what you are doing, because this is connecting all possible solutions. The pro here is it's easier to make sure you solve for these -4 and 2 correctly. The con is, see how I wrote this and right away? People forget to do the second inequality for some reason. I'm not really sure why. And then I'm going to do another quick example down here. If we get the signs wrong, I see people do something like this, where they're like, okay, this is going this way and that's going that way. You are never, ever, ever going to have 2 dots with arrows going the same direction. Because if that was the case, if I needed them both to go the same direction, I would not need to say both of these numbers. I could say x is greater than -4, and that would take care of this entire thing of x greater than 2 as well. Your arrows are never going to point the same direction. Ever. Now with compound inequalities with ors, or disjunctions, you have 2 inequalities that you need to solve at the same time. Well, this first one, -3 is greater than x, and x is greater than or equal to 1. I didn't have to do any solving whatsoever. For some reason, I wrote a 0 there, but I don't have to do any solving. They are both already solved for x. If I want, I could rewrite this. So x is on the left side of both of them. I recommend that. I'll do this one in blue and then this one in green. So in blue, I have a -3. In green, I know I'm going to have a 1. So let's put a number between the two of them. I'll put a 0 there. I'm also going to add in a -5 and a 3. The reason being is when I go to graph this, x is less than -3. I need to go smaller than -3, so I need a number on that side. When I go to graph x is greater than or equal to -1, that's a closed circle at 1, and they are going greater, so I need a number on that side. When you have the word or, if you think of the word or like in a boat, they stick out the side. Here's your boat. There are your oars sticking out. Okay? Again, they are not going to point the same direction ever. Ever, ever, ever. They might point at each other, but that's opposite directions. That would have been an and. Now over here, we add 1 to both sides. -3x is greater than or equal to 6. Divide by -3. When we divide by a negative, we have to flip that sign around. After I solve that, I immediately write an or, so I don't forget to come back and do this other one, where 2x is greater than 6. So x is greater than 3. So I've got a -2, and I've got a 3. I need a number between there, which, well, a number between there, I'll put a 0. It's going to be a little bit closer to -2. I know that this is an or, so I'm going to have things sticking out the side, so I'll make that a -3. I'll make that a 4. So in blue, at -2, I have a closed circle, because it's an or equal to, and it's less than or equal to that. At x is 3, we have an open circle, because it's strictly greater than, which means it's going that way. So, observations for the graphs of and inequalities. We connect the dots. And in graphs of or inequalities, we think of ors. They point opposite directions. The symbols of and inequalities have to face the same way. So we have things like 2 less than x less than 10. They have to be like that, because if I said something like this, I need to have a number that satisfies being bigger than 2, but also bigger than 10. Correct? That seems easy enough. Well, if I need a number bigger than 2 and bigger than 10, I would just say a number bigger than 10 and I would not have to deal with this. So that'd be completely pointless. It's extra wasted effort. So we do not do that. The symbols need to face the same direction. Ideally, we're always going to be going smallest to biggest. All right. So we should almost always have these less than signs, although greater than signs also would be fine. Now the symbols of OR inequalities can be the same or different. They can kind of do whatever they want. It kind of all depends on which side the x value or whatever variable is on. Okay, our x is always on the left, are they always on the right? Is one on the left, one on the right? They get more choices because you have to write an OR, you get to write them either way. So for now, we're going to write inequalities based off of the graph. So to do this, we're first going to identify where our open circles are. So I've got a -1 and a 3. I know they're open, so I know that I'm going to have strictly less than and strictly greater than. And I'm going to always, always, always put x on the left for these. So I'm going to have x is less than -1 or x is greater than 3. That's my final answer. I'm always putting x on the left because then I can use the arrows to help me figure out which symbol I'm going to be using. For this one, my values are at 2 and a 5. My stuff is between them. I'm connecting the dots, so I'm going to put my variable between them. I'm going to go smallest to biggest. 2 is less than x is less than 5. When you're done with each of these, you should pick a value or two to make sure it works. So for this first one, if I picked 1, is 1 less than -1? No. Is it greater than 3? No, it doesn't work for either one of those, so that's out. If I picked 4, is 4 less than -1? No, but 4 is greater than 3, so it satisfies that piece, and we're good. For this second one down here, if I picked a number 3, is 3 between 2 and 5? Yes, so that's good. If I picked a 0, 0 is smaller than 5, but it is not bigger than 2. Because it's AND, it has to do both of these. If it was an OR, it only had to do one of those. All right, so now let's kind of add these things all together. We have an AND function, or an AND inequality, I should say. I'm going to add 1 to all three sides. That gives me -2 less than or equal to -2x less than 6. Divide everything by -2. When I divide by negative, I'm going to flip the signs around. I don't like having them written greatest to smallest, so I personally am going to choose to write -3 less than x less than +1. This symbol sticks between the x and the -3, but since now I have the x on the other side, I had to flip it around again. Same thing with this piece and this piece. When I go to graph this, I'll have a -3, I'll throw a 0 there, 1 there. At -3, it's an open circle. At +1, it's a closed circle. And I'm between the two, so I connect the dots. Down here, this next one is one question. It's not two questions. I need an x value that does both of these. So for the one on the left, I'll subtract 5. So I've got -3x is greater than 3. When I divide by -3, I've got x is less than -1. Or, I immediately have to come do this one as well. -x is less than -5, which means that x is greater than +5. So I've got a number line where I've got a -1 and a 5. I'll throw a number between here. Well, halfway between there would be 2. And I'm going to throw not a 0, because that was a -1, not a +1. I will throw a negative, I'll say that's about a -4. This is about 3 away. They're about the same size. Try to make them all about 3 away, which means that would be an 8. At -1, I have an open circle, and x is less than that. Or, at 5, I have an open circle, and x is greater than that. My ORs point outwards. So here's a spot for you to cover, or write what we covered in this lesson and what things you're not 100% clear on. I know I went through these very, very quickly. Feel free to pause, rewind, and rewatch as many times as necessary. Hope everybody has a great day.